Today we'll be looking at this question. It's a word problem. There are two numbers whose sum is 72. One number is twice the other. What are the numbers? There are two numbers whose sum is 72. One number is twice the other. What are the numbers? Since we do not know what the two numbers are, we can simply represent them with variables x and y. And from the question, it says that the two numbers have a sum of 72. So we can say that x plus y is equals to 72. So the sum of the two numbers is 72, and it can be represented or denoted by x plus y is equals to 72. So x plus y is equals to 72 is equation 1. On the other hand, the question also says one number is twice the other. One number is twice the other. So what we'll just simply do is to choose which of the numbers or which of the variables is twice the other. In this case, we'll choose x as the larger variable. So x will be equals to 2y, since we're saying that one number, in this case x, is twice the other, in this case 2y. So we have a second equation, x is equals to 2y. So we have two equations now, and the first is x plus y is equals to 72, and then the second is x is equals to 2y. So since there are two unknowns, the two equations are sufficient to solve for x and y. Usually when you have solving equations, two unknowns, there are usually two equations, three unknowns, three equations. So once you're able to spot any three equations for three unknowns, then you can solve for the variables. But in this particular question, there are two equations, there are two unknowns, and the two equations are sufficient for us to be able to solve the problems. So x plus y 72 is the first equation. X is equals to 2y is the second equation. Note, in that second equation, x is equals to 2y. Note also in the first equation, we have a value of x, which we can replace with 2y. So instead of saying x in first equation, we can simply call it 2y. That's what we're going to be doing. We will be substituting so that we can solve the equation. So from the second equation, x is equals to 2y. And then we can see x in equation 1, or in the first equation. We can therefore substitute with 2y, just as I had mentioned earlier, and that's what we're going to do. So the first equation, x is equals to 72. So instead of x now, we'll replace it with 2y. And that will give us a new equation. 2y plus y is equals to 72. And if we simplify it further, we have 3y is 72. And we can simply divide it by 3, that is both sides, in order for us to eliminate the 3 on the left-hand side so that we can solve for y. So whatever we do to the left-hand side, we do it to the right-hand side because it is an equation. So like we just mentioned, we divided through by the coefficient of y, and the coefficient of y is the number multiplying y in this particular case, and it's 3. And that helps us to solve the equation. So y is equals to 24, but you remember that x is equals to 2y from equation 2, second equation. So x is equals to 2, and we have solved already for y. It means that x will be 2 times y, which is 2 times 24. And therefore x is equals to 48. So from this we know what the two numbers are. We know that the first number, 24, and then we know that the second number is 48. So we have established that The two numbers are 24 and 48. So we'll just check to see how they satisfy the question above. So the sum of the two numbers is 72. That is 24 plus 48 is 72. So that's correct. And one number is twice the other. Yes, we can clearly see that 48 is twice 24. So this shows us that the two numbers 24 and 48 are solved is correct. Thank you.